great price. The device Photoshop-like program. We're going to switch over right now to Amazon Live. So we're going to bow out, come back in, and I'm going to start over on this. Sorry to start over, but hey, that's what it goes. Bye. See you in a second. Hey everybody, Kent Martz here. Thanks for joining us on Amazon Live today. We've got this going out on the live stream to everyone in the world out there. For those of you that don't know, Amazon Live is a platform they launched last year that is full of live broadcasts. If you go to Amazon Live, which you probably have since you're probably watching this on Amazon Live, we are in there with a lot of beauty and skin and jewelry and all sorts of stuff. Not a lot of technology channels out there. We're, as far as we can tell, we're one of the only technology channels out there. We talk a lot about astronomy and astrophotography and birding and sports optics and STEM education toys, things like that. Today we're doing focus on astrophotography. Paul is apparently walking into the frame.
No, I just thought it won't work because you have to take it off the Wi-Fi and connect the Wi-Fi here.
Mm-hmm. Bluetooth?
Nope.
Paul, you're hiding behind the camera. Paul's trying to figure out a way to get my screen off my tablet into his switch so he can show you what's going on the screen. I don't have chat up over here either. So if you're out there on Amazon Live right now, you can chat us up. If you're out there on a live stream, you can chat us up as well. There's Paul. He's going to walk over there, bang on the computer, and he's mulling this over how to get the live image off of my screen so we can broadcast it easily and you can see what's going on. Paul's not feeling good today. He's more grumpy than he used to be, than his usual good old self. So we'll get to chat up here in a minute. So if you have any questions, comments, observations, whatever. Today we're talking about the IEXOS 100. It's over in your carousel on Amazon Live. You can pick it up for a great price. The device is designed for DSLR cameras and lens systems, which many of you already have, or small telescopes like a 70 or I'm getting ready to put on an ED80. I'm going to show you how to hook up a camera to an ED80 as well. So here we go. I've got a DSLR setup. We have a camera adapter that we sell that allows you to easily connect your camera to the telescope mount with what's called a mini Vixen dovetail. So we make that. It's longer than about anything else out there in the market that'll attach to a camera. There's some short ones, but you couldn't balance the camera real well by moving it forwards and backwards. So we came up with that hot foot right there. The Exos 100 is dead simple to use. Very simple, very easy to get started, but yet very powerful. Once you get past the point of you've learned, you start taking astrophotography, we don't recommend using the program that runs this, ExploreStars, for astrophotography after you get past a certain point, which is real quick. We recommend that you use a Windows computer or desktop and wire in hardwired and control it wired. Why? Because wired is a robust connection that is basically impossible to disrupt. Wi-Fi, somebody next door turns on a microwave oven and you may lose your Wi-Fi connection. Some guy with a ham radio or a CB fires up and keys his mic, you may lose it. You get in a place where there's 3,000 or 4,000 people, all of them with hotspots and all accessing the internet and using Wi-Fi, local Wi-Fi. It's going to interfere. You're not going to get a clear channel, and the mount's not going to really operate well. Ran into that problem when I tried to use a bigger sibling to this one, the Exos 2 GT with PMC8. Harold Block says, more coffee, Paul. Absolutely, but Paul doesn't drink coffee. So which is not to say he's not caffeine free. Hang on, he's digging into something. Oh, it's a rock star or something. Oh, it's a Bang. Yeah, he's getting his caffeine all right, just not through the good traditional coffee, everybody.
Coffee's evil.
So Pekka says, howdy's, Kent and everyone watching. Hello, Pekka. Thank you for tuning in from Sweden. I hope you had a great day. I saw on Facebook yesterday that you had a really nice moonshot. So I hope you're getting some solar images as well. Pekka uses some gear, and he has come a long way in the past year, both in his moon photography and his solar photography.
So,
it's awesome to see that progress.
I've got a question.
Go ahead.
I've taken photo after photo after photo of the moon. And since the moon basically it's always the same side facing me, and it will be for the next eternity, as far as I can see.
Effectively, yes.
What can I do to make it more interesting?
What can you do to make it more interesting? Start using longer focal lengths. When you take pictures of the moon, you're really taking, when you observe the moon, you really start looking at the terminator. That's where day turns into night. That's the line where it transitions from sun to shade. Why? Because that gives you 3 dimensions. And, wide field astrophotography, which, the moon would come into that. It's not real wide field, but it's not, tiny pinprick either. To put it in perspective, the Andromeda Galaxy, M31 and M32, M31, is 6 diameters of the moon across, photographically. Visually, it's smaller than the moon, but photographically, the thing is huge in the sky. So that's wide field, would be something like that. But you're on the moon with a digital camera. There's only really so much you can do to zoom in. That's where coming up with longer focal length telescopes gives you the ability to zoom in and start taking individual features, crater complexes, relays, valleys, cliffs, excuse me, things like that. You start concentrating on more finer, smaller images of the sun. And Pekka said something I was literally going to say, film the sequence. So what you want to do is, over the 28 to 29 day period of the moon, take a picture of the moon every night, and at some point you have to go get up in the morning, and then you take pictures of it in the daytime as well, and you can create a composite image, not composite, but a sequence image, one after the other, and stack them together and put them in circles, a spiral into the center or something, and be creative on how you place those pictures and show the different phases of the moon as it goes through its 28-day cycle. You can also show how the moon wobbles during its cycle, because if you look at just a sphere, you can see exactly 50% of that sphere. The moon's a sphere, effectively. Yeah, I know it's an oblate, flattened, whatever. Okay, but it's a sphere. Because it wobbles back and forth just a little bit, you can see like 61% of the moon. So there's things on this side of the moon you can see sometimes and not, and there's things on this side of the moon that you can see sometimes and sometimes not. That's always fun to, over the course of a year, animate a GIF that shows how the moon wobbles back and forth. All sorts of creative projects to do, but after you shot day 4 of the moon for 6 months, a 4-day-old moon, it starts looking the same. Some people play with the contrast because you can create what effectively is a geological map, a materials map of the moon, because you can see where it's rich in titanium and other minerals. And Pekka says, and the captured sequence in AstroStacker 3, and then sharpen the picture that pops out from AstroStacker in RegStack 6. Final touch up in Photoshop or GIMP just to powder the noise. So that's powder the nose, excuse me.
Andromeda up in your screen right now.
So what Pekka's talking about in doing the moon is take, 200 pictures of the moon in sequence, almost like a video, and then stack them up and the details that you can tease out of those using the programs he talked about. Astro Stacker 2, there's other programs that'll stack up. Registax is one that will do it, and then again GIMP or Photoshop or something like that to play with the curves and levels and some color contrast as well. So there is a picture of the Andromeda Galaxy. You don't get a scale for how big it is, but you see that central hot point right there in the middle, Paul, where it's really, really compact and then a diffuse brightness out from it. You can see that naked eye, and that's smaller than a full moon. But look look across it from where you can see, and imagine what it would take. Fold it in half, or fold it in thirds, and then fold that in half, so you create fold marks so you get a sixth of it. That's how big the moon is. So if you look out there on the left, sort of where your cursor is pointing, I don't know if everybody can see that. Out there on the left, that big bright spot, that's roughly the diameter of the moon. Okay, so it is a very, very large, bright thing. I am going to say that, is that the background? Okay, that's a background there. Okay, there you go. That's a moon map. The blue stuff is titanium. I can't remember what the red stuff is, but by tweaking the contrast, you can bring out and highlight a mineral map of the moon. So simple photography, and you can do some really cool work to see what minerals are dominant on the moon. Some people can actually see some colors in the moon. I sometimes can, but I think I'm imagining because I want to see it so bad.
I think it's the brightness of it.
It just overwhelms everything, you know. And you got to realize the moon is like a 10% gray. I mean, it's really dark, but it still reflects a massive amount of light. And that's what's cool. So, all right. So let's go talk to the Exos 100 real quick. I've got my camera mounted. I've got a polar alignment. So that's a key thing, having the and using it well. Tripod level. So the tripod is on level. Pointed a good polar alignment. So this axis right here is pointed at the north celestial pole or the south celestial pole, one or the other. And then this counterweight bar right here, straight down, parallel down, and the camera pointed at the north celestial pole, centered on the north celestial pole. If all those things are there, the go-to is going to be pretty darn accurate. So I've connected up to the mount, as we talked about a little bit ago. So my tablet, and let's talk about this. Explore Stars will run on an iPad, Android tablet, or a Windows tablet with a screen of at least 7 inches. I know you want it to work on a tablet with smaller screens or on a phone. It won't.
Yet.
It will, but the buttons will be so small you can't make them work, so it won't work. Although technically the program will run, it won't work. Or you can run Explore Stars on a Windows tablet or desktop computer. Now then, we're working on a app that will run on an Explore Stars app that will run on your Android or iPhone. Couple months out maybe. I know we keep talking about it, and you know, it's not an easy thing to do. It's not a game where you can just make pretty characters and have them do stuff. You know, there's some really technical math involved in that, and some interfacing between phones that knows the screen is this or that. It's not as simple as you're thinking. And hey, you know, we don't have a team of developers to throw at it either. So there you go. Here we go. So I'm going to click on the menu. I'm going to go to the catalog. I'm going to go to Messier. I want to shoot something in the Messier catalog. Charles Messier, he was a French guy looking for comets, and he decided that a lot of these things they saw in the sky weren't comets, and so he I'm going to need a drink of water, Paul. Maybe Tyler or somebody's watching and bring me some water. So anyway, he decided these things weren't comets, ended up with a list of 110 things that aren't comets. So I'm going to go one of my favorite objects. Why? M36, M37, and M38 are all in the constellation Auriga, they're up right now. We're going to assume it's night, although it's day here in the United States. I'm going to tap M37. And because I have auto slew turned off, I have to do 2 steps here. Slew to object, go to object. Here we go. We're going to take a journey through the cosmos as the telescope turns, or in this case, the digital camera turns. And so we're going to go to Auriga, and right on the long-sided boundary of Auriga, we're going to find M37, where M36 and M38 are close neighbors. You can star hop from one to the other real easily. And with this camera at 105 millimeters, it's going to be real wide field. And I'm going to make sure, if I'm really doing this, zoom out where I want it and then tape it down with gaffer's tape or painter's tape. Don't use duct tape or masking tape. That leaves residue. And then you got to clean it all off, and it's a big mess. You don't want to do that. Pekka has a question. I'll answer that in just a second. Focus, same thing. You got to tape it down. And some Amit Dinez said, wash your hands doing all that coughing in your hand. Absolutely, but if I had to stop and wash my hands every time there was a broadcast, wouldn't do it. We wipe this stuff down with some sanitizer wipes as we go through the day. And Pekka says, does the app have a polar alignment assistance? Yes, Pekka, it does. It has what's called a 2-star alignment. And we can actually go through that. I haven't done that on the broadcast in a while. So,
Kent,
yes.
got a question.
Yes. Oh, no, Paul has a question.
So if you look on the screen, what do you do if you hit this screen?
Please wait. Okay, the mount was sort of having brain fluctuation seizures. My guess is it managed to continue to do polar micro step counts, and it's going to go back to the home position anyway, even though it was sort of going, it still kept its counts. We'll see what happens. Went back to where it was, even though it had a little bit of a hiccup. The please wait. If you're on an app that says please wait, and this generally happens, no, not generally, this happens when you have not connected the tablet or computer wirelessly to the mount. So it should say in the future iteration, it's going to say not connected or something like that, right? Please wait makes people go, okay, I'll wait. Like if you're at Wendy's, favorite restaurant, I say, would you please wait? Sure, I'll wait. And you'll wait and wait and wait and wait. Nothing's happening. Nothing's going to happen because you're not connected to the mount with your computer. So I can actually turn the mount off and force this to give me a please wait message because it doesn't see the mount, so it's not going to work like it would otherwise. So please wait means you're not connected. There was a glitch in Windows 10 at one point where you could not connect, and we created a workaround because Microsoft fixed bugs, but they disabled other features as well, and that created chaos for us. And but that pretty well has fixed itself. So Pekka asked about a polar alignment routine. Yes, there is. So we're going to do it real simple. We're going to tap Menu. We're going to go to Settings, and I'm going to do a 2-star alignment. I'm going to tap 2-star alignment. Now, if Auto Slew was turned on, it would take off right now, for a star in Cephas, okay? But this is why I've turned Auto Slew off, and I just leave it off. I live with it off. Now it says we're going to a star in Cephas. Well, I can't see that star because there's a tree in the way. I hit Next. Ooh, Cassiopeia. Yes, I can see that star in Cassiopeia. So what am I going to do? I'm not going to hit Enter. I'm going to hit Go To, and now we're going to go off to a star in Cassiopeia. Cassiopeia is a circumpolar star, and from where this is running, it's going to be right on the horizon in the northwest. But we're creating a triangulation mathematics situation. We're creating what's called a transform. So by going to a known star, the mount knows exactly where that star is, assuming we got a perfect polar alignment. If it's not dead center, you simply use the left, right, up, and down buttons, and it comes up with a 0 in the middle. That means if we press the button, it's going to move at speed of 0 and not move. So I'm going to put 6, and you're going to go tap it a few times looking through the camera or photographically until you get Cassiopeia centered up, the specific star in Cassiopeia. It shows you which one it is. And now we're going to hit enter. So now it gives us another star we want to go to. If auto slew was on, it would just go to that one. And if you couldn't see it, you'd have to let it slew and then go to the next one and next one. This way I can just go, nope, can't see that. Nope, can't see that. Ooh, Arcturus, yes. I can see Arcturus. Go to. And now it's going to go off to Arcturus. And what we're doing is we're triangulating these two stars, and it knows the motor counts to where it should be. And by us, when we enter, we program it and tell it, I had to move it this many motor counts in right ascension and declination to get it centered up. We're going to do the same thing to Bootes, Arcturus and Bootes, the bright star in Bootes. Bootes. Hard to pronounce some of that stuff sometimes. Latin. So notice we're going, 90 degrees to a different direction. Sometimes it'll go down to a star in the southern hemisphere. It's just whatever you can pick that you can see. I can see this star. Once again, I'm going to move it a little bit and create and get it centered up. And I'm going to hit enter. I have now created a mathematical model of how close or how far off of polar alignment I am in both right ascension and declination. So it will now apply that mathematical formula to every go-to we go to from now on. Now, to make it work really good, you're best off, especially if you're using a telescope, to go to a really high-powered eyepiece, 10 millimeter, and get it centered up in the eyepiece as best you can. Or even use a reticle eyepiece so you can get it dead absolute center, right? And now you've created this mathematical model. Now, it's still not polar aligned, but as long as you're using it in what's called pointing mode, point means both the RA and the deck are turning. If we go to tracking, it just turns in RA. It's not applying that mathematical transform. So I'm going to go to pick something. Let's go to, home, catalog, Messier. Let's go to something else. Let's go to M81 and M82, which is Bode's galaxy and the Cigar galaxy, circumpolar galaxies near the Big Dipper. Fairly easy to find if you know how to measure things. Once you learn where it is, slew to, go to, off we go. And this will be a great test if we actually look at it to see how centered up these galaxies are. Now, with a 105 millimeter telephoto lens on our DSLR, excuse me, we're taking really wide field images, so it's going to be hard to see it through the visual back. You might be able to see it after you take a 10 or 15 second exposure to see how accurately we are polar aligned. But as you can see, it's a real simple system to use. Read the directions. The directions always help. But if you've watched a few of these videos and watched some of the videos online, it's really simple to use. It's not hard to use. It's very, very powerful, but very intuitive as well. Compared to how high-end technology mounts are today, we should think closer where or if we complain the prices, comparing the prices. Pekka says, I think I understand what he's saying. Technology today, there's a wide range of expenses. You can spend tens of thousands of dollars on a mount, or you can spend hundreds of dollars on a mount. A lot of it comes down to what you want to do. I believe that learning how systems work and learning the sky is important. If you can push to everything and take great pictures, that's awesome. If that's what you want to do, I'm going to let you do it. I'm not going to complain. I'm going to praise you for it. Personally, I like knowing where things are in the sky. I like seeing things visually. I don't do a lot of, right now I've not been doing any astrophotography, but I know people that do, and I'm out there with them, and I can help them make this technology work really well. So I'm going to be going to the Nebraska Star Party, and I will be doing some astrophotography with this camera and lens, right? So I'll have some real world stuff to show you from some really dark skies. Now this is going to sit here and just keep pointing at that spot in the sky all the way across the sky. Now at a certain point, let's see, it's going to be pointed, it's in the west, so it's going to go down over there, right? Actually, it's going to circle. It's a circumpolar, so it's going to circle around. And this actually, if it tracked it all night, it's going to circle around. At some point, you want to do what's called a meridian flip, which means the camera gets over here on this side of the mount. Real simple to do. You just tell it to go to the same object, and it's going to flip itself around and go back to the same spot and go on down the road. So sometimes Alt-Az mount is unbeatable, absolutely, especially for visual, for very easy use, and especially for beginners. Alt-Az mounts are just, think about a camera tripod. You set it down, you move it left and right, and you move it up and down. Really intuitive, really simple to use. You don't have to learn how to polar line. You just have to plunk it down, and then you have to figure out where things are in the sky to know how to point it, because it's totally manual, right? I think there are some go-to Alt-Az mounts out there, but for astrophotography, because both the up and down and left and right, the azimuth and altitude are both moving, to track that object in a circle across the sky, it's got to go over, actually it's got to go over and down and over and down and over and down and over and down and over and down. For astrophotography, you want to make that smooth arc. Why? Because it keeps that star on the same place. It doesn't make a little jaggy, and a lot of times you can see those in some pictures. But for visual, great way to get started, really inexpensive as well. Some really high quality Alt-Az mounts out there. We sell one. In fact, Noah just came back in. Noah, put up the Mazo one over in the carousel for us, please, so they can take a look at that. So this is how you do it with a camera and a lens you have. I want people to get started and to find success really early. I've had customers who spent money on 127s and big 8-inch Newtonians and go-to systems, and all that big gear lets you magnify what you're taking pictures of, but it also magnifies every mistake you make. A lot of frustration there, right? So I want you to be able to take a picture right off the bat and go easy. So using a DSLR, one way of doing it. Now I'm going to park the telescope, the mount, and I'm going to take off the camera, and I'm going to put on an Essential Series ED80. So this is an 80 millimeter telescope from Explore Scientific. It's over in the carousel, a surprisingly low price. Over there, I'll just say what it is, $899 over in the Amazon Live carousel right now. So I'm going to take the camera off the mount. I'm going to take the camera adapter off because we're not going to need this anymore. And I had it good and tight, couldn't even unscrew it. So move the dovetail a little bit, the camera adapter, unscrew the bail, unscrew the screw using the bail, or just twist it. It's coming off real easy. I'm going to lay this back over here behind me. And here is this beautiful, beautiful ED80. So I'm just going to show you how to do this right up here on the table. First, I'm going to take off the lens. I don't need the lens anymore. Oh, I didn't get a snoot. Noah,
Yeah.
that snoot over there, would you bring it to me?
Point.
It'll be over on that table. It's going to be a little barrel with some threads on the end of it. Through on 6, 5, 6 or something like that. No, that's, man, I'm going to step off camera a second. It should be in a plastic bag. There it is right there. Yep, that's it. Luckily, we had it all laying right here in the studio. Thank you, Noah. Hey, Noah, come say hi to the camera. No. Noah said hello to the camera. I expect him to walk in like this and go, hi, everybody, and walk out. So, all right, so I've got this little snoot right here. It's just going to go into the camera just like an eyepiece would, right? So here is what's called a T-ring. This looks just like the back of the lens I just took off. It's got threads on it. Going to screw on to the little snoot, and it's going to click on just like a lens would. And now I just simply stick this right where an eyepiece would go and tighten it down. I have now attached my camera to this ED80. You can attach the camera just like this to about any telescope. Now, I'll tell you something. To do photography with this, I need another extension tube. This little tube right here can screw on and screw off. I need to put another one on here I just haven't done it. I should do it for accuracy, but I haven't done it. You need another one of these right here on it. For example, this is going to work. So now I'm going to pick up, I may have to reframe the camera there, Paul. And I'm going to be very careful. Slide this on.
Pull it backwards and over.
Okay. I know about where the balance point is, so I'm going to put it there. Notice I'm always keeping a hand on it until I know that I've got it tight. So do what?
Backwards? About where you're at. Keep going. There you go. Good job, Ken.
Is that framed up pretty good?
Yeah.
Okay. So, same thing. I've got the camera attached to the telescope. The mount is going to work exactly the same way. Let's check balance real quick. So, let's check the right ascension first. This is the one that mirrors how the Earth turns. Well, look at that. We can tell it's very telescope heavy. So, I'm going to tighten the clutch just a little bit. I'm going to put these counterweights all the way down because I know from experience that 2 is not enough.
Yeah, you need one more.
But you know what? We don't need one more.
You do need one
more. But we can get by without one more.
Okay? No. I tried that, and when it works.
See, I've got
90%, 85%.
I've got a good balance here, right? Okay, so here we go.
It can't.
Well, we'll find out if it's going to work or not.
Well, I've already used this exact same setup
Oh, I got a low
out
battery
in Holiday
now.
Island. Remember?
Holiday Island is because the gravity's different. Holiday Island, it's less
That's
gravity
true.
there. Okay.
So it needs one more counterweight.
It'll work here. One more counterweight will make it work better. And you can buy a
Okay.
counterweight from us. I don't know if we have the counterweights up on Amazon Live or Amazon or not, but we need to probably get them up there. So here we go.
Okay.
We're going to go to catalog, solar, and I've got my dust cover lens cap on. Yibbity deep. Sun, slew to, go to. Off it goes. And we're not going to strike the table. Yes, we did.
It doesn't hurt anything.
So it's going to turn around, and if for some reason it ran into it, the telescope hit a leg, it's not going to tear anything up. It's going to sound terrible, but it's not doing anything. It's just losing its motor counts. No big deal. You just have to use your left, right, up, and down, run it back to home, turn the power off, turn the power back on, reconnect the mount, relaunch Explore Stars. You're good to go. Fix what it was that caused it and go on down the road. We're now pointing at the sun. Now, if I was going to do this, I would use a shadow of something and a piece of white paper, and I'm going to use the left, right, up, down buttons to do fine tuning to get the shadow as sharp and precise as I can, and then
You should already have the sun filter on it, though.
You can, or you can just. It's going to get the lens cap's going to get hot. No big deal.
Well, if you don't have the lens cap on, you're going to burn your sensor up.
That's
in
why
your
I said I
camera.
have the lens cap on. If you don't have the lens cap on, you're going to start burning up your mirror or your sensor cover, or
Yeah,
if your
your
sensor's
camera's
exposed,
toast.
you're going to toast your camera really fast. So once you're done, you get the shadow done. I'm going to push the dew shield down so I can take the lens cover off, but I'm not really going to take the lens cover off. And then I'm going to put on the sun catcher that we have, which is back over here. This thing is not designed to fit this one. This is for bigger But we can show you what you're going to do. The lens has reflective film, Thousand Oaks film. It comes with different sizes. Your telescope, you put the foam in, you put your telescope down on it, you cut out around it. You have now hard foam that you can use to squish onto the lens. You want this thing on there solid so that you are not going to come off in a wind, bump, or otherwise fall off, right? So now, whatever the telescope's pointed at, it's going to do it. So we've gotten it there. We left, right, up, and down. What button do we hit to tell it? Well, we're not doing a 2-star alignment or a 3-star alignment. We're doing just a sync alignment. So I'm going to hit the button sync. And now we've told it, I'm now pointing. We're telling it that the mount, and I'm not pointing, the mount and telescope is now pointing at the object we did a go to, and now it's going to use point mode to point at that spot all the way across the sky. Point, which the symbol is a triangle with a P in it, is going to move RA and DEC all the way across the sky. For solar, works fantastic. You're not going to track it the rest of the way across the sky, especially if you've got a good polar alignment. It's going to have no trouble doing it, all right? Let's see, what do we want to do here? So now, we're just going to go across the sky. We're watching it track it across the sky. I always want it to be a little counterweight heavy and a little camera heavy. Now, you can do any combination of those. Front heavy and counterweight heavy, telescope heavy and front heavy, camera heavy and counterweight heavy, whatever. Okay, so we know I'm telescope heavy, so I can be nose heavy or camera heavy. Why? Because we want to manage how the gear train is engaged. If you haven't perfect balance, that gear train can actually, the teeth of the gears in the worm can actually lose contact, and then it just floats. Now, this is belt driven, so it's not going to lose contact in the belts, but the worm gear could engage, disengage, engage, disengage, depending on how the load is managed. That way, if you've always got a heavy on one side in RA and heavy on one side in DEC, it's always going to be the same. Now, I'm not talking about fall over heavy. I'm just talking about slightly heavier, okay? We haven't talked about the belt drives at all. Okay, some people will go, oh, you know, this has, you know, periodic error, and, you know, I can see it, you know, twitching and stuff. Okay, that's fine. Absolutely, you're right. But I'll ask the question back to the customer and say, have you tried taking astro photos with it? No. Well, why not? Well, because I can see it's got some periodic error and it has twitches. But have you tried to take pictures with it? No. Okay, well, guess what? The answer is that the periodic error, except for one instance, is so minor that the scintillation of the sky, the twinkling of the stars, overwhelms the minor amount of periodic error. What's periodic error? Where a gear train runs either fast or slow. So a lot of times you'll see it run fast, and then it gets past the error point and it slows back down, and it creates, on really high magnification, it can create blurring of the stars, absolutely. However, modern astrophotography doesn't rely on routines where you teach them out where the periodic error is. It relies on a guide scope. You put a guide scope here, which is a little telescope with a little astro camera, and it looks up in the sky and it finds a bright star and it locks onto it. And the computer, you're running into the computer, or if you have a guide camera that has onboard processing, you actually can just plug it into the ST4 port, and the guide camera then works to keep that bright star it picked on the pixel that it's on. When it starts to drift off, it knows what signals to give to tell them out to move. And it's just going to keep continuously adding that input into it to keep that pixel on the same star. Sometimes it gets real aggressive. When periodic error shows up on the guide chart, which is a chart you can see if you wire your guide camera into a computer and then into the mount, you can actually record charts and see how aggressive the guiding is in right ascension and declination. You can see it gets real aggressive, and then it comes down and it smooths out. And then, you know, 9 minutes later, it's going to get real aggressive and smooth back out again. Okay, we know that's there. You know, you pay $10,000, $20,000, you can get rid of periodic error in the mount. Or you can buy an Exos 100, spend $200 or $300 on a guide camera and solve the problem that way. Wonder which one is, least less expensive and much more budget friendly. Yeah, I think we all know the answer to that. So, what time is it?
It is
39. No,
2:40.
2:40. All right. So we've now started taking pictures of the sun. We can play with the focus. We can play with the exposures until we get the right combination. We're going to be shooting probably ISO 400 at 1/250th of a second. Not long exposures, and just play around with it till you get an exposure that looks good. And take notes. Take notes while you're doing it, so you can know exposure number 1 was this, exposure number 2 is that. What you got, Paul?
I would suggest when using a camera, go to the manufacturer's website and look at their native ISO. The native ISO is where the least amount of noise and the least amount of everything is.
Right.
In the Sony a7 III, the native ISO is 800.
So shoot 800.
Right.
Right.
So when you tell them ISO, we always want to make sure that they understand that they should be shooting, if they can, because there's no aperture on these telescopes.
Correct.
If you should be shooting at your native ISO, especially if you're doing long exposure.
Actually, there's 2 ways to control when you're doing astrophotography. Shutter speed, right? You can change your shutter speed. You can change your ISO. There's one other thing you can do. You can actually create a mount. If you need less light, you can create a mount with a hole cut in it that's smaller than the diameter of the telescope, and reduce the amount of light coming to the sensor that way. That's really not what you want to do, because when you decrease the amount of light going on the sensor, you're lengthening your exposures. Although there are some technical reasons why it might work to help cut down scattered starlight. It's all a big balance. You experiment, you figure out what works for you and what you like to do. So,
yeah, the better the camera, the faster the pictures.
So we don't have it back here. I was going to show.
What are you looking for?
I was going to show our. It's over there in the carousel right now. You can see it. It's the reflex sight.
Oh,
sorry, it's not. Somebody grabbed the one here.
It might be in this orange box.
So it's a sight that'll go into the Mini Dovetail hybrid 2-in-1 finder base that goes on every telescope we now sell, Essential Series and higher. So where did it get off to? Okay. Anyway, it's a new product. We've been selling them like hotcakes, but don't put butter and syrup on them because they're not edible. It's a reticle sight. It's a 0 power, designed to be used with both eyes open. It's a fantastic device that you can use to find your way across the sky and see where the telescope's pointing. Also, over in the carousel, we have a book, Scientific Astrophotography. It's a very in-depth look into the science of astrophotography, written by our senior engineer, Jerry Hubble. It's a, if you want to know all sorts of really deep details in how this all works and why, it's a great book to buy. I've read it, when I went camping over a week, and learned a million things. I need to reread it. It's under $40 over in the carousel today. Scientific Astrophotography. Yeah, I know. It's just gone. It was here. Is it in this box right here? Nope, that's not it.
Could be.
Nope, that's not the SKU. I can see what the SKU is.
Could be in the box.
It's gone. Oh well.
Why would people take?
And that's not it over there. Stupid, man, I got a throat tickle. Anyway, off we go. So we can go to somewhere else. This is going to sit there and just go. Now, I set my tablet so it doesn't go to sleep. Now, there is a way to program this mount. If it loses communications, it's just going to continue to do what it was told to do until you turn the power off or you tell it to stop. So I do it. I leave it on, so I want to make sure the connection keeps going. So let's go to something else. Catalog. Let's see how far away Mercury is from the sun. Here we go. Mercury, slew 2, go to. We know Mercury is always close to the sun, and that's how close Mercury is to the sun on an angular basis. So let's go to Venus. Venus, we know it's up because the sun's up. Go to. Here we go. We're going to go to Venus now. Venus is going to be farther away, but still close to the sun because it's inside the orbit of the Earth. Let's see. What else do we want to go to? Can we go to the moon? Is the moon up? Let's see if the moon's up. Menu. Catalog. Catalog. Solar. Mercury. Moon. Moon. The moon is not up right now, so it's below the horizon. Can't go to the moon. Back to the catalog. Mars. Mars is not up right now. The tablet knows. The tablet knows all. Jupiter, not up right now. Saturn, not up right now. Uranus. We can go to Uranus. Let's see where Uranus is located.
I can see that.
Here we go.
Can you? I don't think you can see it, can you?
Yeah, absolutely. It's a pale blue dot. It's a very aquamarine color. You can see it. And it's clearly not a star because stars, even in telescopes, are pinpoints. It is clearly a little aquamarine blue-green disk. Tiny, but yet a disk nonetheless. So there we go. Now we're looking at Uranus. Let's see, what else? Catalog, Neptune. Can't see Neptune. And Pluto, let's see if Pluto is not up. Let's see, what else? Just playing around here. Is Ceres up? Ceres?
Noah
Yes,
says.
it is. There it goes. We're going to the asteroid Ceres.
Kent,
Yes, sir.
Noah says that it was almost named George after King George.
Ceres?
No,
Uranus was almost named
Uranus.
George,
Uranus.
but he got
Uranus.
That's probably.
Herschel, the guy that discovered it.
Herschel, the guy that discovered it, decided to pitch George.
Yeah, because George just would not be a good name for a planet. Don't
George.
think. So if you're with us on
I'm
Amazon
from the planet
Live,
Bill.
we would love to give you a shout out. You tell us you're watching. Likewise, if you're on Amazon Live and you like what you're seeing and want to see more of this kind of content, you can click the follow button and you'll be able to get notified of when that is. Osmosis 007, howdy. Is there a plan for the PMSA to be compatible with a cell phone interface, sub 7-inch, for those of us who haven't jumped into astrophotography? Yes, there is. Been working on it for a while. I'm going to guesstimate we're a month and a half to 2 months away. That sounds, when I say month and a half, that sounds pretty final, doesn't it? That's a guess. 2 months is what we've been shooting for the last couple of weeks. So I think that may be doable. It's going to come out, Explore Stars Plus will come out, and it will be compatible with Android and then iPhone as well. Bluegrass McGee. Hi, Kent. I have this exact scope and mount. Most fun grab-and-go scope setup ever. Great show. Thank you, Bluegrass McGee. We appreciate that endorsement. You know, put that out there on your social media streams. Put a review up on Amazon Live, on our Amazon product page. Those things help us immensely. You know, there are people out there who will post negative reviews on stuff who we don't believe ever have touched the product, but they like to say bad things about it. But we love it when we see people post out there on their streams comments like that with pictures to prove it, because the proof is in the astrophotography now, isn't it?
Now this is
There, Mr.
this is
McGee.
I was looking at it earlier and trying to figure out what I could do with the moon. See, now if I
That's
need
a
to call
fake-
Elon, my buddy Elon,
That's a fake picture.
I call my buddy Elon and have him send me up. No, actually, this is from NASA's website.
I don't know. That looks.
Kent, that's where I got it.
I
was
believe
NASA.
it still looks. You sure it was NASA? NASA, not
Yes,
fake
it's NASA.
Because that looks superimposed.
No, what it is, they're using a really long focal length.
Still looks.
It's real Kent.
Still looks.
All right, hang on just a minute.
superimposed.
I always have to prove stuff with you guys, and you never take my word for anything.
No, I'm just saying it. Just my sniffer goes off.
Okay, so here we go. Hang on just a minute.
Does it say if it's a NASA picture? It should tell us when and who took it and what camera it was, what platform it was on. ISS is going to be my guess here. So all NASA photos will have that on it.
Yeah, this darn thing. Right, zoom in.
I'm looking.
See? NASA.gov.
I'm waiting for it to pop up. I don't see where it says NASA.gov. Can't see it.
Yeah. There's position. There you go.
There you go. I can't use copywritten images, but I can use that because it's NASA.
Sure enough, still looks fake.
It's not fake. It's from the International Space
I
Station.
didn't say it was fake.
You said it looked fake,
Bingo, that's what I said.
which
It
implies
looks-
you think it's fake.
It looks fake. I'm wondering if it's a composite picture.
It is not a composite picture.
I don't know.
This is how
What
you
does it say
get.
underneath it? What does the cut line say underneath it? Make me go away so we can see it full screen. Because the people on their phones are going, I can't see anything. Yeah, Pekka says you should not see the moon because I can see it now. What does it say at the bottom? I can't read it. It's too small on the screen. What does it say down there, Paul?
Yeah. Just a second.
I see it says Expedition 50, International Space Station. It's over the Pacific Ocean, northwest of Guam. There we go. Pretty cool.
Why do I always have to prove everything?
Because I am skeptical of every picture I see on the internet because people do things all the time. They steal a picture of the moon from somebody and superimpose it over a
So-
Greek temple in Greece
So-
and claim it as their own. Or they will put a picture and say, you know, on May 29th, Mars is going to be the same size as the full moon.
No.
And, well, I'm skeptical of every picture, and I
So,
encourage everybody to be skeptical of all social media you see.
I did an entire episode of one
Fake
of our
moonshots?
programs on how to shoot the moon and make it look huge. The way you make it look that big, because it is, in this picture, it's abnormally big.
Yes.
But
And
how
it's
you make it look
long
abnormal.
focal lengths, absolutely.
Long focal length with something in front between you and the moon, because everything's between you and the moon, with something in front, and that moon looks abnormally large. So if you want to get the giant moon over New York City, you're going to have to sit back on the other side of New
miles
Jersey.
and miles and miles away.
Yeah, and hit it with
Right.
like a 500 or 600 millimeter
Longer
camera
than that,
lens.
probably.
Yeah, really long lens.
I'd like to find this original picture because all the original NASA pictures have all of the metadata listed. Who took it, what camera, the
Well, it
exposures,
tells you
all that
who took
stuff.
it.
Yeah, it'd be interesting to see. So Pekka says, yes, we are source critical people. We need sources, knowing where they came from. You know, there's sometimes I see people out there on social media groups that just, you know, people claim it's theirs and people pick it apart and everybody decides that, yeah, it really is a real image. Well, guess what? That's a scientific process, isn't it? If you put a picture or an idea out there, a hypothesis, you know, this is what my study shows, you do that, and then everybody tries to poke holes in it, And when, hey, Scott, come here and join us on the screen, won't you? But drop your box. So just step in. We don't get Scott on the show very much. So, scientific process is put yourself out there and let people try and poke holes in it. When people can't, it eventually becomes a scientific theory.
Kent was
We're talking about scientific process. I said, go back to that picture real quick.
Yeah, you often hear the word theory thrown around a lot, okay? But in order for an idea to, like...
In science.
Yeah, no, there can be lots of ideas,
Yeah.
okay? But
Kent was claiming this picture was fake.
Let Scott finish.
okay. But then that migrates up to kind of formalizing it into a hypothesis. And then hypotheses can become a theory. That takes a lot of work, and
Right.
usually takes a lot of scientists working on it.
And I'm applying it
different
to
angles.
pictures like that. I said, that looks sort of fake. Well, it's from a NASA feed, so it was nasa.gov, so we're going to go with, it's a real picture. But it does sort of look fake. And, I see, and Peck is out
but
there.
just looking at something and calling it fake or even real,
Either way,
that's not.
I don't take it at face value. When I see
But I will
astrophotography
say, though,
pictures,
is it looks beautiful.
it is beautiful.
Yeah.
I see a lot of beautiful pictures
Right.
that are fakes,
Right.
composites, and all astrophotography is a composite, except for single exposure pictures of the moon and the sun. Everything's going to be stacked up in their composites. But
Sure.
some I go, oh, that's beautiful, and I think it's, I believe it to be real. Others look sort of weird, and I go, and I approach it with a more critical eye. And I looked at that with a critical eye going, boy,
Sure.
I want more information. It looks fake. And, we explored, we did a little research and came up with it. Chances are it's not fake because it is on nasa.gov.
You know what's cool about the amateur astronomy world, unlike many other fields of science, is that you can actually get involved in professional/amateur
Absolutely.
projects, and you can really do the process of science where you're collecting data. Your name might even appear on a science paper.
Get cited.
And this is also part of the process of science. So it's opinions get thrown out, biases hopefully get thrown out. These are all things that can happen and have happened in science, but that's not the process of science. And so if you think of the way that science works, it is something that is always ongoing, as trying to portray a more accurate picture of nature.
Right. That's what the pursuit is.
That's the pursuit,
Is
right?
having a more accurate depiction of nature.
Right.
Yeah.
So when we recently the Explorer Alliance went to Mount Wilson Observatory, and we saw Wendy Friedman. Now, Dr. Wendy Friedman is known for studying something called the Hubble constant. Okay. This is a yardstick that Edwin Hubble came up with to measure the size of the universe. Well, since Edwin Hubble's time, okay, back in the maybe 20s or 30s when he developed this, scientists have been trying to refine this constant, okay, and it is based on measuring standard candles, which mean standard types of stars and their brightness.
Cepheid variables generally.
That would be one of them, for sure. There are others. But they get, when you're taking, if I walked into a room and I had a recorder, and one time the noise is playing at some level, and then another time it's playing at another level, or I get too close or too far away to the speaker, or there's static on the speaker, this causes some randomness in the recording.
In the data.
In the data, okay? And so if I plotted out the decibels on all of those on a graph, okay, then I would see, what was predicted, okay, based off of me setting the volume to a certain level, okay, versus what really happened, all right? This is what the astronomers are doing to measure the Hubble constant and other things that they do, other ways they measure things. So they have been able now, Wendy Friedman and her group have been able to reduce that randomness, that uncertainty down to like 1%.
And why is that important? I mean, huge endeavor, massive amount of observations.
Right.
And why is it important? Because it answers a little piece of the question every human asks: why are we here?
Yep.
That's what it is.
That's true.
It's
That's true.
another little answer.
Right. We want
a
to know
little
our place
slice.
in the universe, right?
Exactly. Why are we here right now today like we are? And it helps answer that question.
That's right.
Right.
So the James Webb Space Telescope, they expect, with its light grasp and its ultra-sensitive instruments and everything, that they will be able to reduce that uncertainty maybe another 10 times.
And Scott, we're talking about the first science images are going to get released, I think, at 10 or 11 o'clock Central Time, July 12. That's coming up. That's like Tuesday.
Okay.
I think so.
Very cool.
Everybody's saying that if you thought the first pictures from Hubble were amazing, the James Webb Space Telescope's first science images don't even compare to the
Right.
Hubble.
Right.
You know, that's just a picture versus what James West is going
That's
to
right.
do.
And Ken
Yeah.
and I both have friends that are wonderful, amazing astrophotographers, and some of them are so good that their benchmark is the Hubble Space Telescope pictures.
There are people taking pictures now with our gear and other companies' gear.
Sure.
Amateur level gear. You know, $10,000 worth of gear total, who are taking pictures of the Eagle Nebula as good as the Hubble Space Telescope's original pictures.
Yeah,
You know,
original. Yeah,
original pictures.
The original
The
pictures.
original pictures.
The original ones weren't so good.
You know,
okay, but
Jerry Hubble is doing exoplanet research and confirmation from NASA using.
yeah, and by the way, Jerry Hubble works for us.
Yeah,
so-
Jerry Hubble works for us.
Yeah.
He's our senior engineer. He's using a $300 diffuser filter and confirming NASA exoplanet candidates for NASA using a 165 millimeter telescope from Explore Scientific.
That's right.
And a mount
Yeah,
from
isn't that
Explore
amazing?
Scientific.
Yeah, that
Amazing.
You can do this with a backyard.
Yeah.
It's effectively a backyard telescope.
Yeah.
So
But he takes an extremely scientific approach.
Right.
But he knows exactly what he's doing. All right, so Scott, we're past my 3 o'clock cutoff.
yeah.
I do have work to do today.
Okay.
Besides this, this is work,
right.
but I have other
It is
things to
work.
do. It's nice to get Scott on every once in a while. And for those of you who don't know, Scott's the founder and president of Explore Scientific. We haven't had him on the show very much. Always good to get him here. He is on a lot of the shows, but he hadn't been on Amazon Live very much. So
lot.
for
Yeah.
all of those
we have
people,
quite capable people here for that. So
yeah, but I know where Paul's over there and Noah's over there. I'm just a guy up here rattling off stuff. So Scott, I appreciate that very much.
thank you very much. You guys take
Yeah.
care and have a great weekend.
So we're getting ready to sign off. If you have not followed us, please click that follow button. If you find the content compelling and learning from us, that's what we want. Obviously, this is a sales channel, but we want you to learn as well. No matter what gear you have, we want you to be inspired to get out there and do astrophotography. On behalf, well, next week's schedule is going to be Global Star Party. I say, no. It's going to be, what's Monday? Monday. Oh, how do you know? How do you know? With Dr. Daniel Barth. He might
See-
be in the studio.
Yeah,
Tuesday-
how were you supposed to know?
Yeah, how do you know? I
Nope.
just had to think about it. Tuesday is Fun Day Tuesday with Annie and Lucy. Wednesday, First Light Chronicles. Thursday, On the Wing. And Friday, right back here, Made the Loop 2. Focus on astrophotography. On behalf of everybody here at Explore Scientific, and especially Paul Newton over there in the control booth.
It's Reverend Colonel Paul G.
You
Newton.
hear, he paid $9 to get a ordainment, and he went to school for auctioneer. He can roll it off like an auctioneer.
I'm a trained auctioneer, and the
Honorary
Reverend
title.
portion was free. I
Oh,
didn't have
free.
to pay for that.
That makes it even better. And Noah Menard over there in the Marketplace Control Center. Thank you, Noah, for doing what you do. Can you give us a wave, Noah? He gave us a wave. He's happy to do that for us. I'm Kent Martz. See you next week right here on Amazon Live. Have a fantastic weekend, everybody. Bye-bye.
Thank you for watching our 24-hour-a-day live stream here at Explore Scientific, where we show you all the programs that we run live in front of a live audience. Programs like Global Star Party, On the Wing for birders, First Light Chronicles for beginners, and Focus on Astrophotography for astrophotographers. We bring in astronomers and explorers from around the world to answer your questions live. But there's so much cool information there that we decided to package it all together and run it 24 hours a day. We're also on Amazon Live, where we do deep dives into our products and our gear. There's so much important information as we share the education, the experience, answering questions from the audience, that kind of thing. So tune in, and thanks for watching. If you want to see amazing Milky Way views, you want to observe the stars, you want to hang out with astronomers, but you love art and you love music, you're going to want to come to the Arizona Dark Sky Star Party, September 21st to the 25th at Oracle State Park in Oracle, Arizona. It'll be an amazing event, and I know you're going to love it. Well, hello everybody, it's Scott Roberts, Annie Scarborough, and we are here for Explore Alliance Live. And so what
It's definitely live.
What's that?
It's definitely live.
It's definitely live. That's right.
And we know,
What you were
and we know
hearing
Scott's
at
coffee's hot.
It's
I was
hot.
saying, and we know your coffee is hot.
That's right. So we were listening to a little piece of the presentation from Dr. Wendy Friedman. She's an astronomer, cosmologist type of astronomer from University of Chicago, and her work, her defining work, has been on something called the Hubble constant. Now, this is something that Edwin Hubble came up with as kind of a yardstick, a measuring, a mathematical measuring tool to measure the size of the universe. Since he came up with it, it's been refined, and the number's been refined by measuring what they call standard candles. Okay, so those are certain types of stars, certain ways of measuring brightness or energy from the universe, and then trying to statistically remove noise out of it to get closer and closer to a theoretical model. Okay. Wendy Friedman and her colleagues, I think they have it down to a certainty of like 1%. Okay. And they are looking to refine it even further. So it was real exciting for us to be at the Mount Wilson Observatory during a time, a historic first, where the George Ellery Hale family, the extended family, was able to get together to finally meet one another, maybe for the very first time in their lives, and to talk about the legacy and importance of George Ellery Hale, who died in 1938, I think. Lived a relatively short life, only 50 some odd years. But in those years, he built 4 of the world's largest telescopes in succession. He developed the entire field of astrophysics. He developed a journal called the Astrophysical Journal, which is still published today. He created the American Astronomical Society, which is what all the professional astronomers belong to today. And recently, some new developments where they're encouraging amateur astronomers to join the American Astronomical Society. In his spare time, he helped build out the city of Pasadena, helped Henry Huntington develop the Huntington Library, which is an incredible 130-acre estate and amazing archive of science books and all kinds of books. He also developed the California Institute of Technology, otherwise known as Caltech. And So a very busy guy, didn't really have a lot of other time on his hands to get his family together like they did over this last weekend. We were invited to give or to set up and broadcast live the event. So if you had a chance to watch it live over last weekend, you got to chat and see some of this activity as Ed Krupp from Griffith Park Observatory gave a special talk. Sam Hale, the grandson of George Ellery Hale, gave some inspiring talks, and the president of the California Institute of Technology was there on hand as well. And then the second day, they went to Mount Wilson Observatory, listened to Dr. Wendy Friedman talk about the Hubble constant, which was developed at Mount Wilson, and to talk about her work on the James Webb Space Telescope. She'll be one of the very first observers to use that instrument, and so it was a real honor. We got to see her talk, got to have dinner with her. It was just really, really cool. And then they went off and looked through the historic 100-inch telescope where the some of the measurements for the Hubble constant were worked out. So, Annie, you've been studying the James Webb Space Telescope recently.
Yeah, just in the last week. I and am new to the education world, and so I'm in the middle of a speech class, and I had to pick my own topic. And when I was going through the TED Talks that really caught my attention, I was, because we're going to explore scientific. So that's kind of, it's like, oh wait, there's a telescope. We're talking about a telescope. Let's read that. And so let's watch that. And so I was really, really amazed. And in fact, I was telling Tyler about it today, and he goes, "Where have you been, Annie?" Sorry, under a rock. So, but it just really inspired me to think there is so much more out there, and especially whenever the gentleman that was talking, he was talking about new planets and how they're going to be able to see new planets and discover those and things like that. And so it's going to open up exploration really, really big. So it's exciting. It's exciting.
The
So
telescope did that for us in it's been up there for like 3 decades now, 32 years, I think it's been up there collecting data, still working today. But Jay West will be another, will leapfrog over what Hubble Space Telescope did for us. And so we're going to get to see the universe in a whole new light, so. Amateur astronomers, Annie, a lot of the astrophotographers compare their 60-hour, 100-hour-long exposures or whatever to the Hubble Space Telescope. That's kind of their benchmark.
Oh,
You're about
okay.
to get a new benchmark. Okay, with Jay. And the problem, a hurdle for them also will be is that Jay West images in the infrared, and you and I were talking about it earlier today, and you were talking about the gold that's on the mirror and mirrors, and the gold reflects more infrared. It's higher performance in infrared.
Yeah. Well, it's really neat how because I know as we were talking today, you said they started this journey in 96, I think you said. They started this whole thing in 96. It's 96. And so it's just crazy to think about how far technology has come and how much further it's probably going to come even more. And so, the things that they've had to overcome and had to think about and achieve in order to even be able to get it into space is absolutely amazing. So I think what was the lady's name that was speaking? I'm sorry, Scott, but we just watched the video on
Wendy Friedman.
Okay, so did she say that was as thin as hair? Is that what she said in her talk? That
it was atoms thick. She might have described it like that, but it is very, very. That's optical coatings, including the coatings that are on our telescopes, are they're the way that they're applied is they put the polished optic, into a vacuum chamber. Okay, they pump out all the air. Okay, then
Okay.
they have a way of driving or vaporizing the materials that they want to use. In the case of Jay West, they use gold. Okay, so they had gold pieces in there. They had an ion gun flowing an ion plasma onto the gold. Okay, now it's in a vacuum chamber, so it's making this cloud of gold that's covering everything, including the optics. Okay,
It's
and
crazy.
so it's very, very, very thin. They usually put an overcoat to protect the coating. In the case of Jay West, I'm not sure if they had to do that or not, because there is no air in space to oxidize the coatings. And gold doesn't
Yeah.
really oxidize anyways, not like aluminum will, for example. You know.
Yeah. So did they? So then they mainly chose gold because of the oxidization. I can't even say it.
No, they chose gold because of the infrared reflectivity.
That's
performance
right.
in infrared, because it's an infrared telescope. You know.
Yeah. So I didn't know if it was because of both of those things. Like I know silver probably doesn't do as well as gold, but I didn't know if maybe it just sounds like it sounds like a material that is more durable and will achieve the things that they're needing. So, but it was as we were talking today, the other cool thing was to think about how strong it is. I think you said that you could see the details of a penny 24 miles away. And then
away.
Yeah,
Right.
and then whenever we started talking about it, then we started talking about, okay, well, how far can we see in a horizon? And you said like 3 miles is as far, if we're at sea level.
It's 2.9 miles or something, you know.
It's
so
like
if you're,
nothing.
I'm not even 6 feet tall. I'm like 5'10". Okay, so I can't quite see 3 miles out. Okay, even on a crystal clear day, looking out over the ocean at sea level, I'm only going to be able to see 3 miles out. You get some elevation though. Now you can start to see much further out, and many, rock climbers and stuff like that, or if you've been to the top of a mountain, you might be able to see 100 miles out. Okay. But imagine holding a penny out, somebody's 24 miles away.
You can see that. That's crazy.
Now, what's the date on this penny here? Okay. That's what Jay West can do. Okay, so.
I mean, and when it's in our hands, we have to like bring it up so close to our eyes just to see it.
Right.
You know,
I'm using a magnifying glass, right? That's right. So
that is so crazy.
Super, right.
Yeah.
So
well, it's interesting. I think somebody on the chat is asking about what we think about civilization out there, and so. That's a great question. I mean, there's so many different kinds of things that could be living and growing that we don't, you just never know.
One of the big problems I think humans have is that we separate everything, right? We separate everything. You're separating the whites from the colors and putting in the washing machine. You're separating, which side of the road you're driving on. You're separating which ring you put your finger, you put your ring. We separate everything, okay? And therefore, we think that we're home base, okay? And everything out there is separate from us, okay? So when you ask the question, are there civilizations out there? We happen to be part of the out there, okay?
That's true. That is a true statement.
Absolutely connected to everything else in the universe. So if you want to ask, is there life out there in the universe, your first answer is yes, okay? Because we're here, okay? It's self-evident, all right, that we're already here. Now, is there other planets out there that have life on them? Probably, okay? Probably, because it happened here, okay? And so I think one of the big fallacies that humans keep falling into is that we think that we somehow occupy a special place in the universe. It started with us thinking in Ptolemy's time, okay, that we were the center of the universe. Earth was the center of the universe, and everything went around us, okay? And up until really the turn, when the 1900s are getting established, Harlow Shapley is at Mount Wilson using the 60-inch telescope, measuring globular star clusters. Have you ever seen? I mean, have you seen globular star clusters with your telescope?
Not with my telescope. No, I have not.
Yet. Okay. Well, when you do, you're going to be blown away. They look like snowballs of stars. They're beautiful.
Oh,
I had to-
wow.
I had to
Have you
wipe
seen-
mine down because I was seeing globular clusters. Once I got rid of that, I was fine.
He was fine. Okay. Globular star clusters are some of the most beautiful objects in the sky, and they can be seen even with small telescopes. There's some real bright ones out there, okay? But they look like snowballs of stars, okay? M13 is like a really famous one, the Hercules cluster, okay? Well, these globular star clusters are formed around the center of our galaxy, like in a halo, okay? And so Harlow Shapley started making very careful measurements of these globular star clusters and measuring the distances to them, okay? Probably using the standard candle method, of how he's measuring how bright these stars are, okay? Oh, these are a lot fainter, therefore they must be a lot further away, okay? And so he learned after his measurements that, oops, not even the sun occupies the center of the universe. Up until that time, general accepted reality, as we want to call it, okay, was that the sun was in the center of the universe. Wrong. We're not even in a special part of the Milky Way, okay? And then we discovered, oh, well, the Milky Way must be the center of the universe. Wrong again, okay? No, it's not. It's just one of billions or trillions of galaxies out there. So we do not occupy a special place in the universe, okay? Therefore, it's easy to infer that life is not as miraculous as it is, and how, that we think it's uncommon, okay?
Yeah.
We think it's uncommon. And some people, some theorists, or people putting forward hypotheses that this is the only place where life existed, because we have not yet really detected, irrefutable, hardcore proof. Now, we're not like, with on the Tonight Show with an alien. Okay, we're not. I mean, it would be really cool if we were, but that hasn't happened yet. Okay, to our knowledge.
And I think.
So
I
maybe
think that
Johnny
I think
Carson
that
might have been an alien, but So.
You never know. I think that one of the things too is, though, as we wrap our minds around life out there looking like us, and it doesn't. Sometimes
There's
it could be
another
a small. It could be a small thing, microscopic living thing that's out there that we don't know
Let's
about.
take COVID. Yeah, I would say that COVID is a living thing. Okay, out there.
Yeah,
it's a virus. Okay.
Yeah.
It collectively has a kind of intelligence, okay? It certainly kicked our butt, and right? So, and things like viruses can actually survive the environs of the vacuum of space, Yeah. And they're not the only things, all right? So there's possibly bacteria that had been blown out of our atmosphere by big asteroid impacts, for example, could have, with the solar wind, kept blowing out until some of it collected, rained down on Mars, So there's an idea that, the genesis of life here, as amazing that kind of creation event is, may not be that unusual in the universe, all right? So we... as far as being very technical, humans are still not super ultra technical. I would say they just found, I don't know if you saw this, but they just found some human remains that are now dating 1 million years earlier than the oldest human remains ever found.
Wow.
So it puts humans back to about 3.5 million years. All right, well, let's just take the last 50,000 years. How much did we technically really know? Not much, okay? Then you keep
Yeah.
compressing it to, maybe the last 500 years. 500 years, it started getting pretty interesting. The last 400 some odd years, we got the telescope. Okay, so and now today, we go all the way from Galileo's kind of not very great telescope to the James West Space Telescope.
Yeah, they were
Yeah.
300,000 years old, according to the
What's
carbon
that?
dating.
You're talking about these
What was?
remains?
Yeah, the remains.
Oh,
3 million.
Huh?
he said 300,000.
What's the byline on this? What date is this?
Yeah.
That's why I got to 2017.
Go a little further. Well,
Like-
if you honestly think about it, and like when she showed the Eagle's Nest nebula, and she called it a nursery of creating stars. If you think of everything in that aspect, then you have to come to the conclusion that there must be life somewhere. I mean, that's being created. Life's always being created
It's
here.
right here.
I mean,
It's right here.
there's you can't just assume that this is the only planet that has life on it. I mean, it's so it's just, I don't know.
Yeah,
It's really
we
interesting to
can't
talk
say
about.
we can't say for certain that it is. We can't. Also, you
Yeah.
can't say that it's not. Okay, so that's the deal on that. Most people who study science, follow this kind of stuff, do realize the distances involved. Okay, we are light years away from other stars, and so that's the deal. It is very intriguing to think about. If you went to Pekka and Connor and you guys that are really kind of commenting on this, if you went to the Jet Propulsion Laboratory and you asked the scientists there, okay, what is it that we're studying now? I mean, we kind of went through an era in astronomy where we were making maps. Okay, we were saying, okay, plotting this, and there, voila, we got a constellation. Okay, then we started trying to refine the positions of the stars. Okay, then we learned how to measure the stars. Okay, the distance to the close stars. And then we started measuring, and then this expansion thing of, which started really and got kicked off big time in 1923 when Edwin Hubble discovered a variable star in the Andromeda Nebula. Okay, that happened at the 100 inch at Mount Wilson. And suddenly we went from, oh my goodness, the whole universe isn't just the Milky Way. There are lots and lots of these other island
A lot of
universes.
stuff out there.
Yeah, and so that went from, I don't know, probably thinking initially there's a few hundred of them to a few million of them to a few billion of them, and now maybe it's a trillion, and maybe there's parallel universes. So that's
Yeah, there's no
cap.
count. I don't think we can count how many things are probably out there. It just keeps going and going and going, which is amazing. I mean, what a great exploration, to be able to be a part of and
Sure.
and watch that journey unfold. I mean, I know that they had major things to overcome, from getting the telescope into the rocket to getting it out into space and unfolding it, and there was just a lot to do in order it to be able to do that. And so, and I want to know who thought. Okay, I just can see them trying to figure out, this telescope is way too big to fit in a rocket. Let's figure out how to origami fold it down so it'll fit in there.
It was an origami. It was just amazing. I mean, I think Wendy said in the talk there was like 100 points of failure. There was more than 100 single points of failure. I think it was like 300 and some odd. Just crazy. Okay. Numbers of likelihood of failure on this instrument. But the point I was making about the Jet Propulsion Laboratory, if you went to the Jet Propulsion Laboratory today and asked them how are they studying, what is it that they're really after to study in the universe, it's not distance, it's not the spectral analysis so much, okay?
Yeah.
What they're searching for is life, okay? And they're very serious about it, okay? So,
yeah. Well, that's why they're constantly looking for new planets. I mean, the first time I read about, I think Jerry Hubble. I read an article on Jerry Hubble, him figuring out. I can't remember what kind of planets they are, but because of the way they pass, the light that comes, like you could just see the shadow of it, and so that's how it'll fit in.
The iconic Galileo scope is perfect for emerging astronomers to learn about the science of optics and the inner workings of a telescope as they build their own 50mm refractor. The kit requires no tools and includes everything to make a compact, reliable telescope.
Hey friends, Kent Martz here with Explore Scientific. And Paul, I'm hearing the sound about 5 seconds late.
No,
It
it's
sounded
not.
like
It's
the
just
thing went
messed
like
up.
through both ears or something.
Okay,
We've
is that
been
what it
having
was?
We've been having a little bit of
Yeah,
issues today, and I'm working it out as on the fly.
Yeah, it was like I started talking and all of a sudden the sound came through my earbuds, and that was disconcerting to say the least. Hey Scott, how you doing?
I'm good, a little tuckered out from traveling back and forth to California. I was at the, we had a very special weekend with the George Ellery Hale family. They had a reunion that was celebrated at California Institute of Technology in Caltech, Pasadena. And then we went to Mount Wilson Observatory. There were great talks at both places. It started off with the president of Caltech was there talking to the extended family of the George Ellery Hale family. George Ellery Hale, I think, died 1938, something like that. I think he was only in his 50s. But during his lifetime, he built 4 of the world's largest telescopes, including the Yerkes 40-inch refractor, the Mount Wilson 60-inch telescope, the Mount Wilson 100-inch, where they discovered, these 2 telescopes, they made major discoveries about our galaxy and about the universe. At the 60-inch, they discovered, Harlow Shapley discovered that the sun, it was believed all the way from the time that, from Galileo's time till that time, that the sun was probably the center of the entire universe. And so Harlow Shapley, by measuring the distances to globular star clusters, was able to determine that was not the case and that we did not occupy a special place in the Milky Way itself. Then in about 1923, after the completion of the 100-inch telescope, they were able to photograph an individual variable star called a Cepheid variable in what was called the Andromeda Nebula at the time. They just thought it's kind of a circular, pinwheel of a gas in the Milky Way, and he determined that this nebula was indeed another island universe of stars, and so voila, other galaxies are discovered, and the universe expanded overnight by millions and millions of light years, containing what was then thought to be millions and millions of galaxies, which now is considered to be billions of galaxies or maybe trillions of galaxies. So, the search goes on. What was so cool is on, at Mount Wilson, Dr. Wendy Friedman, who, by the way, is going to be one of the very first astronomers on the James Webb Space Telescope. She gave a lecture about the refinement of something called the Hubble constant. This is something that Edwin Hubble came up with as a measuring stick to measure the distances of galaxies and So there's been this continued research and work towards refining that number, and they use standard candles of different stars and their brightnesses to determine these distances. And so these standard candles, which also include supernovae and different types of luminosity that they can detect, redshifts, these kinds of things, help us to understand the size of the universe. And so it was just it was a real honor to broadcast these things. So we, Explore Alliance did broadcast them on several channels, including Mount Wilson's own Facebook social media channel. So it was nice. Yeah. So and then on July 4th, I got to see some fireworks. That was cool. And we visited dealers, and we and then circled back here to Arkansas to face triple-digit temperatures. It was so hot. It was so hot yesterday. But anyhow, Kent and I have been talking a lot about the upcoming Star Party, the Arizona Dark Sky Star Party, and we encourage you to come. Kent, why don't you give some of the lowdown on the second Arizona Dark Sky Star Party? You were at the first one, is that right?
I was at the first one. It was in 2019. And Fabulous Dark Skies had never been to a star party in Arizona, have driven through a couple of times, but never been to a star party there. Went to Lowell Observatory for the rededication of the Clyde Tombaugh telescope there. And on the way back, we pulled in and some dark places and just pulled off the side of the road at a desolate exit. And Clint Brandon and I had some viewing there, but it wasn't like the wonders of the dark sky that we got at Kartchner Caverns, which is southeast of Tucson. And for a variety of reasons, we've moved it to Oracle State Park, which is northeast of Tucson, blocked by, is it Mountain Lemon? Is that correct?
It's blocked by Mount Lemon. Actually, the dark sky reading is very, very close between the two sites. And, Kartchner, I think, is about a tenth darker on average. But, in this situation, other things affect just how, dark things look, and this has a lot to do with, transparency, humidity, dust, these kinds of things come into play as well. But I think we're in for a treat. We did, Mike Wiesner and I did an on-site inspection and used the SQL meter to get light readings that were, 21 plus. And it wasn't even dark yet. It was like, I think it was like 8:30 at night that we did these readings, maybe more towards 9 o'clock. So, it doesn't really start to get super dark until, maybe after 11 o'clock, something like that. So
when you were out there, obviously in September, it's going to get dark a lot earlier. So
that's right.
We haven't said the dates. September 1 through 25.
September 21, not September 1.
Oh,
September 21.
Yeah. September 21. Yes, we're having a 25-day star party.
Okay?
So,
no, it's going to be September 21st to the 25th. And so it's going to be really great. Now, something else that's happening in the community of Oracle is that the Friends of Oracle, which is Friends of Oracle State Park, is a supportive group of the state park area itself. But there's also the Oracle Visitor Center. And so they're getting musicians, artists, the Catalina Council of Boy Scouts will be there doing their activities. We can expect talks at Biosphere 2. We got Biosphere 2 coming up. We have people like that have been selected, like Adam Block and Fred Espenak and some other luminary type speakers I think you'll really enjoy. We will broadcast live some of these talks, not all of them. we hope to have some amateurs that are astrophotographers that will show live views through their telescopes while they're out there. So, but it's been a long time since we've actually gone to Arizona for these star parties, and so we're hoping that you consider making the trip out there. I did mention I was in California, and I did see the high price of gasoline that was out there. But as you get out more towards Arizona, fuel becomes cheaper and cheaper. And so I think that if that's any consolation for you, that's something to think about. We are also working with Biosphere 2 as far as accommodations. So you can get rooms there. You can buy I think it's a 5-night package. Ends up being $120 a night. They have dormitory style rooms, but I never visited a dormitory that's this nice, so it is, they give you fresh linens, and it's a nice setup. You will share.
There's no room service.
No room
There's
service.
No linen service.
There are B&Bs there that you can get, and if you like the Airbnb type of thing, those are available as well. So there's no shortage of rooms for the event, and we think I think it's going to be a lot of fun.
So if you want to book a room at the Biosphere, you have to go through us. They do not have a reservation system. They're not a hotel. So these are rooms that are generally set up for visiting scholars and college students and things like that. And so they don't have a mechanism. So you have to go through us to reserve those rooms. And Scott, do we have a page up for that?
Yes, we do. Sure.
Okay.
Yeah. Yeah. So let's recognize some of the people that are watching right now. We have Tarek watching from the UAE. He says, hello, Beatrice. Harold Locke is watching. Beatrice says, hello, Kent, Scott, and Paul. Annie Scarborough from customer services watching right now. Mike, did you pull over and get a lawn chair out? Okay.
He said he was watching, but traveling.
Okay. Oh, he was like on the road or something? Yeah.
Yes.
Yeah. Mike Wiesner's watching. Mike has been very instrumental in getting things, he's been our man on the ground there in Oracle. He lives in Oracle. He can attest to its dark skies. And he's made some really nice Milky Way shots from Oracle State Park. Norm Hughes is watching. And who else? Osmosis 007. He's probably a James Bond fan like I am. I love that.
Osmosis 007. He's been on a number of our broadcasts and asked him some really great questions. He's a great addition to the family. Absolutely. Good to see him on. So I'm looking for the link.
For the link?
The Biosphere. Is it on the Arizona page?
Here, I'll find it for you. Hold on.
Because I've got my screen up. I can share. Here, I found it. No.
You found it? Okay. Yeah,
so, Paul, you want to share the screen for me?
What's that?
Paul, you want to share the screen? Okay, Paul can share my screen through the.
Okay, sounds good.
So, the picture, you think of college dormitories, you say dorm rooms, and we've all seen dorm rooms on college campuses and dormitories, but there's a picture down the walkway, and that is just attractive as can be right there. $512. If you're coming with a group and there's going to be like 6 of you, let us know and we will make sure that we block you all off together in the same dorm room, or we'll separate you if you're not that good of friends, or you want to meet some new people as well. We can block you off so that you have, rooms with people, if you want to do that. And
the other thing I'll point out here, it's not a hotel. And unlike hotels usually have like things like special taxes that add on to your cost. sometimes parking, which adds onto your cost, sometimes resort fees, these kinds of things. So they'll come up with you'll see advertise a lower price for a hotel room, and then you end up paying, if it's $100 or something, or $120, it quickly adds up to like $150, $160 before you're all said and done per night. And so, but this is not the case here. This is roughly, I think, $120 a night, something along those lines. So,
Right. And no hidden fees, no hidden taxes.
Right.
It's just
Right.
$512 for the event.
Right. But you can't pick up the phone and get room service. No. Okay. So that's the deal.
And the towels you get on day one are the towels you use the whole week. Scott, did you take this picture, or was this
No. This is just a very nice photograph of the Arizona desert region, and
It looks like the sidewalk is wet. That's why I was going to ask.
You're talking about this picture here?
No, I'm talking about this picture up here on the screen right now. So
let me see.
It's not on anyone else's screen, Ken.
No, that shot of the Casita Rentals is from the Biosphere website.
Yeah. So the sidewalk looks wet. That's why I was asking. So they took it.
Yeah, it was probably right after a monsoon rain or something like that.
Right. So,
but
it's
you
not
guys will remember that
season.
Biosphere was an experiment to see if people could live in an enclosed environment, making their own oxygen and their own food and all of that stuff, for a Mars colony. So,
and while, it had problems, they had to put in more moisture and air from oxygen from time to time, but it's not a failure, because science is not about failure. Science is about learning from failure. And the things they learned,
they need failure to know where so you push the limits until you get failure, and then you start to learn from that. If everything's going fine, you just don't know when it's going to go bad, right? So
and you definitely want to, long before you get to Mars, you want to figure out where failure point is. Most assuredly, if you've never been to dark skies, this is an opportunity to get there. It's going to be great weather. It's not monsoon season. The highs, be warm. It'll get cool in the evenings. Deserts are hot during the days and cold at night. So prepared for, to be in the 80s or 90s and maybe the 50s or 60s in the evenings. But we got 4 spectacular nights back in 2019. If we get 4 spectacular nights again, we'll be doubly lucky. But it is extremely dark. The first night the sun goes down, if you've never seen a dark sky, you're not going to be, and you're good at finding constellations. Yeah, you're going to be blown away because you can't find the constellations. There's so many stars that constellations are not apparent. And that was the most overwhelming thing I had, back in, in the 2000, 2001, when I went to the Nebraska Star Party for the first time. It was jaw-dropping, and you need to experience that. And we're going to be doing astrophotography. We're going to have people showing you how to do it, helping you do it. Bird watching. September is the fall migration, and there will be a host of birds migrating through that we will be. I believe we've got a bird watcher expert who's going to be leading some talks, and we'll have some binoculars there for people to borrow. I believe they check out binoculars from the visitor center as well. So it's going to be a good time. We're planning to
bring some optics for people to use, of course. And the one special optic that we're going to bring, Kent, is the new Alpen thermal imaging optic. Okay, now this is really cool. This is something that just fits in your hand. Okay, you press down the button, and it's beyond seeing in the dark. Okay, anything that's warm is going to be picked up over the background areas. So we're going to be setting these things up on tripods overlooking the watering hole that's out at Oracle State Park. And you're going to see some amazing animal life at night. So I think it'll be very cool.
Because the things you see at night are completely different than the things you see during the day generally. That's
True.
going to be cool as well. And Scott, I'm going to have the BT giant binoculars out there. I
Nice.
cannot wait to see what it looks like. So we have one pair here, we have more coming, but they're 120 millimeter diameter telescopes mounted side by side as a pair
Mhm.
of binoculars with two eyepieces. Will
Yeah.
blow you away. The sky is going to look. I can't wait. The moon looks amazing through it. I cannot wait to see what the dark sky in Arizona is going to look like through these. When you're using both eyes, the way your brain is engineered to see things
Right.
in a true binocular fashion, it's going to be pretty cool, Scott.
Yeah, I'm looking forward to it. Stargazer Man wants to know, he says, hey guys, where on the Bortle scale does the site sit? I would say it's between a 1 and a 2, okay, is where it's at. I have been to darker sites, but in order to get to those sites, you have to go way out there, way beyond any civilization, you know. So um, I have, I've been at Bortle 1 skies, where the nearest town was like 100 miles away, so um, that's, or 70 miles away. I would probably rate the Nebraska Star Party at Bortle 1. The drive to the next closest town, which is Valentine, is a little bit of a jaunt away. So,
It's 40 miles away.
yeah, yeah.
Yeah,
So,
so
you
I'm
know,
getting
Big
I'm
Bend
getting the
National
map up
Park
right
is
now.
Portal 1, so, but again, you're very, very far away from civilization. We did not want to pick a site where it was only for the most extreme dark sky site, or the most extreme away from civilization. This is close enough and dark enough where astronomers can be satisfied. Deep sky observers, I'm a deep sky observer. I love to do visual observations. You're going to be able to see some amazing stuff from there. Astrophotographers, absolutely, it's going to be no problem. And so you're going to see, you'll see the Gegenschein, you'll see the zodiacal light. The Milky Way looks like a storm cloud overhead, so it's going to be amazing for you.
So Scott, I've gone to lightpollutionmap.info, and
Yeah.
it says it's Bortle 2.
Bortle
So-
2. Now,
Yeah, Bortle 2.
one of the things I learned about light pollution maps, okay, is that they don't tell the entire story of how dark it is, okay, and so this is, I think it was Mike Wiesner. He's very involved with the International Dark Sky Association. He said it's a little bit, it's a good read, but does not really tell you what you can or cannot see from a site. So,
Right. Because
which is-
it's about air cleanliness, it's about transparency, steadiness.
yeah,
things
like in
like that.
Arkansas, we have Bortle 1 and Bortle 2 skies out here, but there's so much humidity in our skies that rarely can you see anywhere near what you could see from maybe a Bortle 2.5 sky from a very transparent, like a desert site, for example. So,
Right. So I'm going up to Nebraska right now just to see what Nebraska says. Nebraska's Bortle Class 1, an
yes,
SQM meter of 22.
right.
So it's just dead dark. It's so dark that when the Milky Way gets up overhead high, you can see your own shadow.
Yeah.
Now,
And
It's a
I
diffuse
believe
shadow.
that you can see your shadow to a degree also at
Yeah.
Oracle. So,
I suspect you can. And it's weird. You turn around, you look at the ground for a while, and obviously your eyes have to be fully dark adjusted, hour and a half, 2 hours.
sure.
And you turn around with the Milky Way behind you, and you start looking and you move, and you can see it move with you. It's a very diffuse, it's not easy to see. You're
Yeah.
casting a diffuse shadow on the ground. It's like, it's pretty cool to see. Yeah, pretty cool
Right.
to see.
Right.
So,
Okay. But I think that's kind
So,
of our things I had to cover for today. The This particular event's going to be amazing. We also have, I would be remiss in not mentioning the Mount Wilson 60-inch Star Party, which will happen in October. So if you're going to our website, you would just do explorescientific.com/events. I'll put that link up there, and you can see all the stuff that we're doing. We will also be going to the Nebraska Star Party this year. And we will be attending Starmus event and doing a Star Party out in Yerevan, Armenia at the Temple of Garni, okay, which is a first century pagan temple. So it looks like something, it looks like the Parthenon or something. It's really cool. And then what else are we doing?
Let's see.
What other Star Party?
Eclipses. Let's
right.
look at eclipses. We've got an eclipse blog up. Paul, you want to get that up? He says,
I can share it.
I've got it right here. He'll
Takes
get
me
it
a
up.
minute. Takes me a minute to find this stuff because I
I know where it is.
wasn't expecting to be called upon.
Here, I can do it. Hold on. This is the 2024 eclipse. I'm actually working on a page for the 2023 eclipse as well. Let's see. Toggle screen sharing. And can I just share one page here? I don't know. Window. Here we
If
go.
you've never seen an eclipse, that too should be on your bucket list. Having seen plenty of eclipses over the years, but I think the closest I got was in the high 80s. But I'm telling you, Mike Scott says 99%'s not it. 99.5%'s got to be pretty cool. But I'm telling you, 100% totality. I guess totality is 100%, isn't it? Totality is an amazing experience that changes you in some way. It sounds weird to say this, but I know people that have seen the eclipse, and they all say it changed the way they look at the life.
Yeah, it's a cognitive
that-
shift is probably the best way to describe it, or
Yeah.
one of the best ways to describe it. Because, I mean, something really does move inside of you. When I saw my first eclipse, total eclipse, I had this feeling in the pit of my stomach that something was wrong, okay? Like almost fear-based, type of feeling. So it was very, very interesting, and you can totally understand once you experience it. And you can see a zillion beautiful photos of it. You can watch videos of it. You can hear people screaming ooh and ah and all the rest of it. That is nothing compared to what it's really like.
Scott, when we were Clint Brandon and I went up to Casper, Wyoming, and we were up on the backside of Mount Casper in the Badlands, and the valley was sort of oriented to the northwest, and there were
Right.
people down this road off to the west of us, and we're watching it. It's nearly eclipsed, and it's just right there. And then the people, half a mile down, you hear them start yelling, and then as they're in the eclipse, half a mile away, and you're not eclipsed yet, and then
Right.
people closer yell, and the people close, then the people right over there 50 feet away yell, and it's not eclipsed yet for you, and then you yell, and then the people on east of you yell, and literally I called it the yell that went all the way across the country, because I think that was one thing that everybody just shouted out in awe, in celebration, in amazement. It's
Sure.
it's really hard to describe that feeling, and
Hey, Scott.
it followed along. Go ahead.
Yeah.
Your camera's doing something funky.
Yeah, I didn't like it after I shared it. So I'm just going to be the guy talking right now. So
Okay.
He'll be the
it didn't like
He's
for
the
me to
disembodied
share. So
voice.
that's why we're having you share. So
Yeah,
That's right.
I would just. just need the links to know where I need to
Yeah,
go.
yeah. I thought I could
Okay.
share.
So,
And I did.
so anyway,
I did share for a little bit.
Yeah.
Anyhow,
You can
anywho,
hit reload, Scott, and it may fix it.
let's see.
or you can kick it. One or the other. So we have two eclipses coming up. One in October of 2023.
There
That's
you
going to be
go.
an annular eclipse, and the annular eclipse is when the moon is too close to the Earth
Yeah.
to fully cover the sun. And so, depending on where you are, if you're very close to the center path, like we're going to be at the October version of the Crossroads of the Eclipses Star Party, we're less than a half a mile. We're literally yards away from the center line of the annular eclipse that comes down out of Northern California and Oregon and crosses, South Texas and goes into the Gulf. We're within yards of the center line. And because of that, the moon is going to be dead centered on the sun, and it's just going to be a perfect ring of sun all the way around. It's like a sun with a big donut hole in it. Now, you have to use eclipse glasses the whole time on an annular eclipse because
Yeah.
you're getting sunlight, real sunlight. 99% sunlight is still bad for your eyes, so you can't do it. And then we're like 2 miles away from the center line on the April 2024 eclipse, and it's going to be spectacular. Then we're getting 4 minutes and 26 seconds of totality where we are.
Oh my God. Yeah.
Yeah, so it's
Right.
going to be tremendous to see. Osmosis 007, it's the best part of being a regional truck driver. All the small towns in the tri-state area, Nebraska, South Dakota, Iowa, getting paid to scout camping locations. Absolutely. You figure if you can figure out how to get paid, do it. Now, we're gonna be having eclipse glasses here for sale pretty soon. It's going to be a fun thing. Get your eclipse glasses when you can. Don't wait till the last minute.
Yeah. In fact, our
And
first batch of eclipse glasses comes in this week. So,
right.
yeah, you definitely want to get ready for it. You don't want to wait. You do not want to wait for the rush that happens, a few weeks,
That's right.
because you might think, oh, it's reasonable to expect that 6 or 8 weeks before the eclipse, I can get my eclipse glasses and then everything's going to be fine. That answer is no. That's a bad idea, okay? Because everybody thinks that, so the crunch to get eclipse glasses happens it happens weeks before. There's no reason for you not to get your eclipse glasses now. You can use them to look at the sun to try to find big sunspots if you want, that kind of thing. But the other thing you should get is eclipse filters or just solar filters, white light solar filters for your camera, for your telescope, because you'll probably want to try to photograph the eclipse, right? And so you need to know how to use those filters and to track the sun. So
And muscle memory. Muscle memory.
Because
Scott.
muscle memory, exactly. Because
I tried to do it.
panics that happen during an eclipse where something goes wrong. I've seen everything from people not recording things to not taking off lens caps to not turning on tracking, just a zillion things, so because when it's happening, you will be so captivated by the eclipse, even if you're a seasoned eclipse goer. Okay, in fact, seasoned eclipse goers have it down to muscle memory. They practice, so when I've been to 3 eclipse expeditions so far where we broadcasted the eclipse. The first time was actually done on 35 millimeter film on Mauna Kea in Hawaii for the science show called NOVA. So I was part of that NOVA film crew. The second and third time was with the Exploratorium, where they're broadcasting via satellite and doing the uplink for NASA and a number of other streams. you get started 3-4 days in advance on site, polar aligning, tracking, going through the motions of it until the actual eclipse comes. So
And Scott, the one that was down in South America that you went to, we
Mhm.
shipped duplicate or triplicates of many things down there. It wasn't a case of just ship one of what you're going to use. We shipped at least two. In some parts, we shipped three things down there.
That's right. Yeah,
to
and
make
you
sure
have
that
no time. If something breaks, you drop something, you trip over a cord and rip something out. You have no time to get another one sent in. And so you just need to have it. So you need to, if you're going on an expedition, a real expedition, and an eclipse would definitely qualify, you need to have backup. And so that's just the way it is.
And we're going to be down in South Texas, and it is an expedition. This is not glamping. This is going
No,
to a
not
place
glamping.
where we're on a private farm. There's one entrance. We're going to have people there checking passes. The only
Yeah.
people who are getting in are going to be registered guests. So you're going to be able to, if you want to, and not camp there, but have a site there, you could set your gear up, leave it. We're going to have security. And if you're comfortable doing that, and then go to a hotel back in Austin or San Antonio or Kerrville or somewhere like that,
Austin
and
would
then
be
come
a
out for the
bit of a drive,
eclipse.
right?
It's going to be, Austin's a hard 2-hour drive. Kerrville's a 2-hour drive or an hour and a half drive. We recommend coming to camp. And
I
it's
totally
gonna
want to
be-
go glamping though.
Well, you can do that. I think,
You
can
can,
pull
and
a
maybe
trailer there.
so we'll see.
You can pull a trailer there. You tent camp with no problem. You're going to have to come prepared with electricity. We hope to have some ways to offer your ability to recharge, but you need to plan on this being an expedition to a solar eclipse and
That's right.
attack it just like you would an expedition to Mount Everest or however you want to
Yeah.
look at it.
But,
you
but we
you
will
wanna
have,
make sure you have everything.
food on site. There'll be,
Right.
you can get hot food there prepared on site. Mickey's Kitchen is going to be there. Mickey is famous for being at the Winter Star Party and supplying people with food all day and all night long. So these star parties are not just for the eclipse. They will be dark of the weekend, dark of the week star parties because they'll be during new moon, of course, and so it's going to be great.
And I think, Scott, that's a critical. This is not just an eclipse event that day. This is a star party leading up to the eclipse.
Yes.
And then after the eclipse is over, we know from experience from what happened in 2017, the roads are going to become grid locked. And you'll get caught in a traffic jam. If you're trying to fly out of San Antonio,
don't make this tight
that
on
night,
either side of the eclipse.
Yep.
No. Yeah, you're going to
Stargazer
want to
Man-
allow a day or two after the eclipse to leave, so.
So Stargazer Man, hoping to make a trip to the States in 2024. My fourth TSE. What's TSC? Total Solar Eclipse. In this private area for the event sounds perfect. Stargazer Man, absolutely. It's going to be, it's not, it's out where it's dark. It's for astronomy people. Come to a star party. We're going to have speakers. We're going to have talks about the history of the Texas Hill Country. We're going to have, it's going to be more than just a star party at night and then solar eclipse and then go home. We're working to make this an event that fills your time and is educational as well, workshops and things like that. So
It'll be fun, and you're going to make some friends out there. So that's going to be
you'll make
cool.
lifelong friends out there at this thing because especially if you're there for 3 or 4 days,
right?
You're going to make friends that you're going to, Norm Hughes is going to be in Hunt, Texas. Norm, there's no reason why, unless you've got a place you're already going to go, you're welcome to come, spend the week with us. Would love to have you, to meet some people that we see all the time and often every day.
Right.
And I look forward to meeting so many people over the course of these events. That's to me, that's sort of the special part of this, is meeting people who are friends that we've never met, but yet we talk to them every day or whatever. So,
Right.
Paul has a picture of you doing the Suncatcher solar filters, a
Oh,
very
yeah.
inexpensive way. It'll fit. We can make one to fit any telescope. If there's not one, or not one that you're sure what your telescope is, all we need to know is the diameter of the objective lens, and we can make a filter for you. They're cardboard with a solar safe film, and they've got some hard black foam triangles that you cut to fit your telescope. I always caution people, make sure it's a tight fit. You don't want that thing to just slip on and slip off.
No,
because
exactly.
because you'll put your eye out if you're not careful, or you'll
Yeah.
burn your camera sensor. So you want that thing to go on there and have to really force it on there to get it on there, because you don't want a hard wind or a good wind or somebody walking by to brush it and knock it off. You want that thing to stay on there, no matter
You'll notice
what.
it's over the front of the telescope. In that video that Paul has up, I demonstrate that the danger of trying to look through your telescope just by wearing eclipse glasses.
I cannot
we
pull
had
the
to-
sound up for that video
can't pull the
the way
sound
I
up.
have it.
So I was talking about is, don't put your eclipse glasses on
Yeah.
and then look in your telescope with no
Oh,
filter.
that's-
So you've got a telescope, no filter on the front,
You'll
like
burn
you'd look
through
at, say, the moon.
filter like a laser beam. Okay.
No, Scott, it is a laser. I mean, it effectively is a very solar-powered laser. It will instantly burn through that film, and I mean, you won't have any warning. You'll hit it, and it just vaporizes that film.
Right.
You
Just
can't
be aware of what
do
you're
that.
doing. One of the other things I've seen happen is people use correctly an over the lens solar filter, and they lean down to look in the eyepiece, and they have forgotten to cover or remove the finder scope, which is, by the way, also aligned with the main telescope, and still light
And
coming
burn
in,
their
and then you
foreheads.
see smoke coming from their hair because their hair's catching on fire. You know.
Yep. So you need to either take your finder scope off or
Yep.
cover it, because there's, and I use the shadow to line it up. I mean, we're going to use our PMC8
Me
systems
too.
to
Yeah.
get things lined up and have it lined up the day. And that's the other great part about coming, is you can get a perfect polar alignment the night before. Buddy has an observatory, but I plan on coming to the Star Party, Norm. We will love to have you.
That'd be fun to
Certainly
have you.
want to shake your hand and thank you for being a part of our family.
Yeah.
But you get there a couple of days early, you can get a dadgum absolute perfect 100% polar alignment,
Mhm.
which is going to make your photography and your viewing easier the next day, because everything is just gonna